Okay, so Learning Unit 3 in the grade 11 book revolves mostly around networks and e-communications. So obviously we've been dealing with, as far as the hardware goes, single computers and the likes, but they aren't really that useful unless you have computers which are connected together to form some kind of network. So your definition of a network is it's a number of computing devices, and we call these nodes on a network, which are connected together using some kind of communication or transmission medium. And the purpose of that is to share hardware or software resources or data or information or whatever the case be. And that definition of a network really applies for things like the school network, but also cell phone networks, the internet. A network is really a connection, a number of nodes which are connected via some kind of transmission medium in order to share something, whether it's hardware resources or software resources or the like. Now, a node can be anything. So a node can be a physical computer, it can be a cell phone, it can be a network connected printer, it can be a Wi-Fi router, it can be a wired router. There are various different, that's what, or definitions of a node. Okay, and a node is any real computing device which is connected to a network. When we talk about transmission medium, we either talk about cables or we talk about wireless, and those obviously come in various different flavors, which we'll discuss as we go along. So the first main way that networks are classified is by area, and the best or the most commonly used type of area network is a local area network. And local area networks are local to a physical location. Okay, so these are all classified by the physical space which the network covers. So the network at Michael House is a local area network. It's confined to the area of Michael House. It's quite a large area because it involves the staff houses and all the rest of it. But generally it's classified as a local area network. And really what you need to know about local area networks is they are pretty much what we can call private, although private networks are a whole other definition. But they are all devices in a particular area which are connected to one another. They don't necessarily make use of an internet connection to connect the nodes in the network. Nodes in the network are connected together, and they don't need an internet connection in order to accomplish that. So even if our network connection is down, you can still play network games on our network, you can still access resources which are on the server or on each other's computers, and that is a local area network. We really do connect to the nodes on the network using our own infrastructure. Some is fiber optic, some is Wi-Fi, some is cabled network, but essentially that's what a local area network is. And the hardware that you need in order to access the local area network is a network interface card and some kind of medium. Okay, that's on your computer, so you'll have a network cable connected to the network interface card on your computer. A lot of your laptops, that's obviously built into the motherboard, integrated hardware like we discussed in the hardware section. And then the network requires various nodes, so printers, workstations, servers, etc., and then connecting devices. So there are things like switches, repeaters, bridges, routers, etc., which are covered later on, but that is what a network means. So there are different types of network media, and the network media which is generally used these days is wireless, but there is cabled media which still forms a very important part of any network. Coaxial cable is a really old technology which you don't really need to worry about. It's hardly examined anymore, but all you need to know is that it's pretty much a wired network which is very old. We then get on to twisted pair, and twisted pair is the most commonly used cable in local area networks. And it's used in local area networks because twisted pair cable, which is usually UTP, okay, which is unshielded twisted pair, and you've all seen those network cables in your rooms before we had the Wi-Fi, and they connect all of these computers, is the most commonly used network cabling in the world for local area networks. And I say local area networks because they have a maximum distance of about 100 meters. Okay, so they're not used for internet cabling, or they won't be used to connect the server room to your houses, but they will be used within your houses, within a computer lab, or within a particular room. We'll all use UTP or unshielded twisted pair. There is shielded twisted pair, which isn't used very much. It's used to stop interference from other devices, and we'll get into that as well. But generally, if you ask what kind of cabling will you use, and it's just a normal network setup, UTP is the correct answer. So there's a diagram of it. Most of your network cables consist of 4 twisted pairs, so 8 wires, and 4 of them are used for data going or data transfer in one direction, and the other 4 in the other direction. Okay, so wires can interfere with one another, which is why we get shielding on those wires. So unshielded twisted pair comes in various different types. The one which is most common is either Cat3 or the most common is Cat5 or Cat6, and they just vary in the speed that they can transfer. Okay, most of our cabling in this room is Cat6, so it does have a gigabit limit, so you can transfer up to 1 gigabit per second. But some of the older ones is 100 megabits per second, which is not too bad. It's still faster than most internet connections. Oops, I think there wasn't much more on that page. So what we have over here is a very versatile wire, and the reason why it's used most often is because it's very easy to install. Okay, it's an industry standard. The connections, making a connection at the end of the wire is incredibly simple. It's very cheap, so that is why it's so widely used. It's quite reliable, it's quite sturdy. And when I say it's easy to install, yes, making the connections at the end of it are quite easy, but the wire itself is quite malleable, okay, and it's quite durable. So that's why it's generally used to install. We don't use it if we need a high level of security or data integrity, then shielded would be better. Or if we need to transmit something over a long distance. Remember, we can't use UTP to connect this computer lab to Baines, for instance, okay? Because it has a 100-meter limit. So we don't use that when we need large distances, but to wire up devices in a room, it is perfect. It does have problem attenuation. Attenuation is the word that's used for signal loss due to distance. Okay, so when we say it has a limit of 100 meters, we mean that the cable has a limit of 100 meters. So if you think about it, if you stand on meadows and you speak at a normal speaking volume, those sound waves dissipate as you get further and further away. So if someone's standing a meter away from you and you're speaking at a normal volume, that person's going to be able to hear. You stand 10 meters away, it's going to be a little bit less clear. And if you stand at the other side of the rugby field 100 meters away, you're probably not going to hear them at all. That's because sound waves dissipate in air. And the same applies for electrical current, which is essentially what is being transmitted in your normal UTP cabling. Okay? It's electrical wire, it has an electrical impulse, and that dissipates over distance because of the voltage and the current, etc., etc. And you'll all know from physics that a cable has its own resistance in it, and the current and the voltage all determine how much current or voltage or whatever is going to come out at the other end. So attenuation is signal loss due to distance. Okay, and various wires have different types of signal loss, but generally UTP is about 100 meters. It's also electromagnetic interference, and that signals from other sources such as machinery can interrupt signals traveling in copper cables nearby. Now, you will have noticed this if you put your cell phone near to a set of speakers. You notice that buzzing sound that it makes. That's because the electrical interference is interfering with the wires in the speakers, and the same can happen to network cables. And this commonly happens if you have a high voltage cable which is carrying power, and then you run a UTP cable next to that. Okay, the electromagnetic waves that a high voltage current produces will interfere with the electrical current in the network cable. So that's called EMI, or electromagnetic interference. Eavesdropping is another thing, because whenever you transfer a current, there is an electromagnetic field which comes out of that wire. And from the field that generates, so in other words, you've got your wire, and the electromagnetic field that is generated by that wire has a particular signature. And if you can read that electromagnetic field, you know what current or what data is being passed through that wire. So it is possible, by picking up electromagnetic fields from a data transmitting wire, you can tell what data is being transmitted across that wire. Crosstalk is similar, but crosstalk is electromagnetic interference across two wires which are running next to each other. So you've got two data carrying wires that run next to each other, and they can interfere with each other as well. And UTP is susceptible to all of those things. Yet we still use it because it's so widely used, easy to install, cheap, effective, and all those other advantages that we spoke about. So one of the type of wire which is becoming increasingly popular, largely because the cost is decreasing, although it's still expensive to use in everyday use, is fiber optic cable. And fiber optic cable transmits data using light. Okay, and this has its advantages and disadvantages. But the main advantage is we can get very high speeds and high bandwidth with very little interference over very large distances. Okay, because light travels so quickly, and obviously eavesdropping is not a problem because light doesn't put out any electromagnetic interference. It also travels incredibly quickly, and it can go an incredible distance. Okay, so whenever we need to connect two parts of a network which are very far apart, or will have high traffic going between them, we use fiber optic cable. So each of the houses in the school, each of the 8 houses are connected via fiber optic cable to the server room. Okay, so what we have is a situation where we can transmit very high volumes of data very quickly between network segments which are very far apart. And that's a huge advantage of fiber optic cable, okay? Because obviously you've got 70 boys in a house. UTP cabling, firstly, is not going to make the distance all the way from Baines to the server room. It's also not going to be able to cope with the volume of data of 70 boys in a house going to the server room. So we use fiber optic cable for those links. Okay, huge amounts of bandwidth over a large distance very quickly. And when you complain that the Wi-Fi is slow, I can promise you it's not the Wi-Fi that's slow, it's the internet connection that is slow. Your pings to the server room, your speed to the server room, there's absolutely nothing wrong with that. So why wouldn't we use fiber optic? Okay, and you can see over there the way the light bounces around inside of the core of the fiber, and how it gets to the other side. So like I said, it is incredibly versatile, and it's got all sorts of things about multi-mode and single mode which you don't particularly need to know. Okay, the disadvantages of fiber optic, and they're kind of quite understated over here, is it is quite expensive, okay, and it is difficult to install. So, for instance, fiber optic needs to be spliced, which requires a machine, okay, a very specialized machine, and it requires specialized skills to be able to install fiber optic cable. So, when we need to install fiber optic cable, we need to use one continuous piece. It's not just like, okay, we need a fiber optic here, so we can just kind of snip it off. and people can plug it into the computer. It doesn't work like that. So to install kind of 70 fiber points in each house is just impractical. Costs a lot of money. It's very sensitive equipment. Fiber optic cables in themselves are sensitive, and it's difficult to maintain. We don't have one of those machines. We need to get people in to splice those things. So that's generally why they're used as the backbone of a network. Okay, they're used to connect network segments together and not for endpoints. And when you get fiber to your home, if you live in Joburg or Durban, you'll notice when the people come and install it, it's quite a mission. And you don't get fiber for every computer in your house. You just get fiber to the router, and from there you'll use UTP. So in essence, it's very expensive. It's difficult to install. So it's not viable for us to connect every one of these machines in this lab via fiber optic straight to the server room. Okay, it's too expensive, and it's not really necessary. Okay, you don't need, each of these computers doesn't need like a 10 gigabit link to the server room. It's just not necessary, and it's impractical. But as far as backbones of the network go in large distances, they're very useful. So where they're useful in my class is each of the staff homes have fiber optic connection to the main school building, because UTP just won't do it. The staff houses are simply too far away. So there is fiber optic going from each of the staff houses to central locations, and then from there, there's one fiber going to the server room. So that is an incredibly useful thing to take note of. Obviously, the next thing we need after we've established some kind of wired medium is a network interface card, and you'll notice most of them use or most of your computers have UTP, okay, so you can plug in a wired network cable into it. And that's the picture of a network card on the side, which your desktop machines will have, but generally most of them are inboard or onboard network cards, which are built into the motherboard. Now, one very important thing that every network card has is a MAC address, okay, which is spoken about over here. And you can get your MAC address of your network card. If I type in ifconfig/all, no, it's -a, okay. What you can see over here, if I scroll up, got a few network cards running on this machine, but this is my MAC address. Okay, let me just enlarge this for you. Okay, so that is 68:5B:35:8D:F0:A9. That is a hexadecimal number. Okay, that is a hexadecimal number, and it uniquely identifies this network card in this machine. In fact, you'll notice that my cable and my Wi-Fi have two different MAC addresses. Your MAC address is unique for every device you have. If you go and look on your phone will have a unique MAC address. It is set by the manufacturer of the network interface card. Okay, your Bluetooth adapter, unique MAC address. Okay, the Wi-Fi on your phone, unique MAC address. Wi-Fi on your laptop, unique MAC address. It is set by the hardware manufacturer, and it is a hexadecimal number. Okay, I think it's can't remember. I think it's 32 bits. I'm not entirely sure at the moment. So when your computer or any device needs to connect to the network, that MAC address is information which is sent with it. Okay, it uniquely identifies. Your MAC address never changes on your network card. Okay. Right. So the other important thing about networks, or LANs in particular, is something we call LAN topologies. Now, LAN topologies is the logical layout of your network, and this diagram on the left represents a star topology. Now, that doesn't mean that these computers are placed in a star like that. They could all be in a row. The point is those computers are connected via cabling to a central device called a switch or a hub. Okay, they're generally called switches. And that is a device which allows a whole bunch of network cables to connect to it. So can show you an image of one of those. Okay, is there one that shows it with cables? There we go. Okay, so that is a switch. So it's this device with a whole bunch of network ports on it, and you basically what you do is you connect all the computers to a central device, and they can all speak to each other. That central device could then be connected to another switch, which could be connected to the server, and you can have as many of them as you like. But the upshot is that you land up with what we call a star topology. And in a star topology, every single device has its own dedicated cable which goes to the central point, which is what makes it a star topology. Because if you draw an image like that, you will eventually land up with a topology or shape of a star. So every one of the computers in this lab are connected directly to a switch. Okay, so they all have its own dedicated cable which goes directly to the switch. The advantages of a star topology are really that you land up with a network point. Every node in your network has a direct link to the central point. So if computer A and computer C want to communicate with each other, they don't have to fight for bandwidth from any of the other computers. Computer A has its full bandwidth to connect directly to the switch, and the switch can then send computer C the information directly along its dedicated thing. Adding or removing a node doesn't upset the network. So for instance, we can easily add another machine to this room and just connect its cable directly to the switch. Okay, we can also unplug a machine and it doesn't affect any of the other machines on the network. It is the most common topology in LANs. Okay, so in this computer room, we're using a star topology. In your houses, a star topology is used because every one of the network points, if you're connecting via a cabled network, is connected directly to the switch. And a problem in one cable only affects that node. It's not going to affect all the nodes on the network. It's just going to affect that one node. The rest of the nodes will keep working without too much trouble. A large amount of cabling is required to connect each node, but because the cabling is so cheap, that's not really a disadvantage, but it is. Okay, if you have 100 computers and your switch is 100 meters away, you're going to need 100 times 100 meters of cabling. Okay, but it is cheap and easy to install. Obviously, switches add to the cost, but that's something you can't really get away from. And the biggest are 128 port switches, which are quite expensive. And if your switch fails, your whole network fails, or that segment of the network fails. So if the switch connecting all of these computers fails, none of these computers are going to have network connectivity. Okay. Yet star topologies are still used because they are the cheapest, easiest to maintain, and the most common. They then move on to bus topologies. Now, all you really need to know about bus topologies is that computers are daisy chained. So computer A is connected to computer B is connected to computer C is connected to computer D, and all the computers are connected in that way. Now, it does require less cabling, and you don't need a switch. But the problem is, if computer A wants to communicate with computer Z, it needs to go through computer B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and then only it will get to Z. And if there's a lot of traffic, let's say computer A is, or let's say computer L is communicating with computer S, and there's high traffic there, computer A, in order to communicate with computer Z, will have to deal with all that traffic in between. Okay, so that medium is shared. So if these two computers have heavy traffic between them, for this computer to go to that computer, this whole medium of this bus topology is going to be busy. Okay, so it's shared. So the bandwidth and the speed is not great. If this computer happens to fail, none of these computers can communicate with one another. So bus topologies aren't used within a computer room like this, but they will be used as the backbone to a network. Okay, they will be used as a backbone to a network. So for instance, all of your houses are connected in the school via a bus topology. So the fiber goes from one house to the other house to the other house. But that's a high bandwidth cable. Inside of your houses, you're still using a star topology. Okay, so that's quite important to note. But all of the houses will be connected via a bus topology. So if that fiber breaks, then everyone is in trouble. Okay, or at least wherever the break is. But that very rarely happens. And you need fiber on the backbone because it's a high bandwidth cable and it's a high speed cable. So there's a diagram of what I was just talking about. You will notice, let's say that that's Baines, that's Pasco, that's Mackenzie, this is our computer lab, and this is the media center. You will see that they all have star topology, so there'll be switches in the center over here. Okay, so those are all network switches. Okay, these are individual segments. Okay, so they'll all have a star topology with UTP cabling. And to connect these segments, we'll have fiber optic cable. So this might be a fiber optic cable, that might be a fiber optic cable, that might be a fiber optic cable, and that might be a fiber optic cable. So we may have backbones connecting it, okay, all the way across, yet their individual segments are still working off the basis of a star topology. Okay. Ring topology, please don't worry about it. It's hardly ever examined. And then it goes through a bunch of different considerations. So what you're often asked to do is you're asked to recommend kind of a network topology or a network cable type for a particular application of network. And you need to read the scenario quite carefully, okay? So generally, if you're asked, if the things are quite a distance away, you're going to recommend a fiber optic backbone. If there are a lot of computers in one space, then you're generally going to recommend UTP cabling with switches, and it's probably going to be a hybrid between the two. And you're going to look at reliability, future growth. Do we need to extend this network? What are the implications going to be? Is there a new building coming? How are we going to cable that building? Generally, internally is going to be a UTP star network, star topology, but to link it to the rest of the network, depending on the distance, you're going to have to use fiber optic. If laying cable is not possible, you may have to say there's a wireless bridge which is going to be used, so we're going to connect different segments of the network wirelessly. But that's all coming up.